Hello, this is Mrs. Brown, and today we're talking about operations with rational expressions. So to start, we want to review combining like terms, because if you understand this skill really well, then it makes it much easier to add and subtract radical expressions. So the first thing I want to remind you is that when I have just an x, that's the same as 1 times x, but 1 times x is x, so we don't usually write the 1. And so when I'm looking to combine, 3x can go with 1x, but not with 5y because they're different variables. So 3x minus x is 2x, and 5y minus 2y is going to be 3y. And so that would be my simplified expression using my rules for combining like terms. So let's look at a similar expression, but this time with radicals. Okay. So when you're looking at this, things that have the exact same radicand, so 2 and 2, are considered like terms. So you can add and subtract them. Just like 3 and 3 can be subtracted or added because they're like terms. It has the same number under the radical sign. And so when I look, I'm going to combine 3 times the square root of 2 and minus, it'd be 1 times the square root of 2, just like it was like 1x. So I treat it like 1 times the square root of 2, because 1 times the square root of 2 is the square root of 2. And now I can just subtract the numbers in front. So 3 minus 1 is 2 root 2, plus 5 minus 2 is 3 root 3. And this is as simplified as I can make it. So again, just like with combining like terms, I can add and subtract when the variable is exactly the same. I can add and subtract the coefficients. When you have a radical expression, the ones with the identical radicands can be combined. The identical square roots can be combined. And the ones that have different square roots, you can't when you're adding and subtracting. So that is very similar to combining like terms. So if you kind of think about it like that, it's a lot easier to kind of figure out some of those problems. So let's take a look at officially the way that they would describe this with math. That makes it look more complicated than it is. But the official way they would say this is, and again, b has to be greater than or equal to 0, is that if you have this same number under the radical sign, whether you're adding or subtracting, you can combine the numbers in front. And that's what they're saying with those particular rules. Okay, and so again, if I wanted to take another example, like say 4 root 7 plus 3 root 7, what's that going to come out to? Well, they're both root 7, so I just can add the numbers in front, which would be 7 root 7. Notice the number didn't change under the radical sign. Again, it's the same as saying 4x plus 3x is 7x. This doesn't magically become like x squared or some other thing. You're not changing that at all. You're only adding the number in front, just like you're only adding the coefficients right here. Okay? If I were to take 5 root 2 minus the square root of 2. Again, this is going to count as 1. So this is like 5 minus 1, which would be 4 root 2. Okay. Now, let's look at some practical examples of that. Let's say that I have the square root of 8 plus the square root of 24 plus the square root of, say, 18. Okay, so when I'm trying to do this problem, at first glance, this definitely doesn't look like I combine anything because these are all different. Except that, wait a minute, isn't this divisible by 4? And isn't that divisible by 4? And I'm pretty sure that 9 goes into this. So they're not simplified, so let's start by simplifying. So this is the same as the square root of 4 times the square root of 2. This is the square root of 4 times the square root of 6. This would be the square root of 9 times the square root of 2. So I can take my perfect squares. This would be 2 root 2 plus 2 root 6 plus this would be 3 root 2. Now, I can't do anything with the 6 because it's different, but I have a square root of 2 and a square root of 2, so 2 plus 3 is 5. So 5 root 2 plus 2 root 6 is my simplified answer. Again, just like we're taking the stuff that you learned yesterday, if I have things that can be simplified, I should be simplifying it. And by simplifying it, sometimes I can combine like terms where it didn't look like I could do it in the first place. Okay? So if I take a look at multiplication, okay, again, as you're looking at the official math here, a times f times the square root of b times g, and again, b is going to be greater than or equal to 0, and g as well. Okay, fancy math saying, you remember from the previous assignment that we could multiply those two together, and that would be like the square root of 42, and we're cool with that. Or we could, what we're doing is we're just saying if you put numbers in front of those, okay, 6 times 7 I still do is the square root of 42 because it's under the radical sign, and now I'm just multiplying the numbers in front because 2 times 3 is 6. So again, the stuff under the radical signs can be multiplied. The stuff outside the radical signs will be multiplied, and you can adjust your answers that way. So 5 root 2 times 3 root 5. Okay. Again, what do? You multiply the numbers under the radical signs, which is the square root of 10. It can't be simplified. 5 times 3 is 15. That's my final answer. So the numbers in front of the radical signs can be multiplied. The numbers under the radical signs can be multiplied. Okay. Now we can take this and use it as part of the distributive property. So let's say I had 3 root 2 times 4 root 5 plus 3 root 7. Okay. What do? I distribute. Okay. I'm doing basically 3 times the square root of 2 times 4 root 5 plus 3 times the square root of 2 times 3 root 7. And so I'm going to simplify. What can I do? I can do 3 times 4 is 12, and 2 times 5 is 10, so it's 12 root 10, plus 3 times 3 is 9, and 2 times 7 is 14. Neither of these have perfect squares other than 1, so I can't simplify. This is my final answer. Okay, so even though it looks different and kind of weird, it's actually very similar to the stuff that we've been doing right along. Again, a lot of the same rules, it's just being applied to radicals, and it just looks a little bit different, and so sometimes people are a little bit intimidated by that. So let's look at one more, which is a binomial times a binomial. Okay, and so when you take a look at this one, what do? We do double distribution. So 2 square root 3 times 4 square root 3. So this times this and this times this, minus 2 times the square root of 3 times the square root of 2. Okay, plus, I'm going to run a room here, square root of 5 times the square root, 4 root 3. Plus, and then that would be the square root of 5, minus square root of 5 times the square root of 2. Okay, and so again, we just go by and simplify it step by step. It's this times this, this times this, this times this, this times this. So when you multiply this together, you get 8 times the square root of 9, because 3 times 3 is 9, and 2 times 4 is 8, minus 2, and that's a 1, so 2 root 6, plus, okay, again, the 5, there's no coefficient, so it's 4 times 1, so it's 4 times the square root of 15, minus 5 times 2 is the square root of 10. You simplify anything that you can simplify. this has no perfect squares, this has no perfect squares, and this has no perfect squares, but this is, so this is really 8 times 3, which is 24. So my final answer, I can't really simplify or add together most of it, but this would be what it would be if I did double distribution on a binomial. Okay? I hope this helps and have a fabulous day.